Hey guys, in this video I'm going to show you how you can train your own YOLOv8 model on your custom dataset to detect any kind of objects. So currently I'm in my final year of engineering and I've been working on a project that is this dental disease detection using YOLOv8. So basically I'm trying to detect any kind of diseases. Right now I've worked on detecting cavities and in intraoral images as well as in x-rays, and further I'm gonna move on to detect the dental lesions like periapical and periodontal lesions. So let's just look at like the current model which I've made. So let's take this image. So as you can see here, I have trained this model for three classes: low, severe, and moderate. And I've like annotated my own images and I've fed it into the model, and this is the output when I predict it. So you can see here this three classes: severe, low, and the confidence scores along with it. So basically, this is what we'll try to make. I assume you've downloaded every prerequisite that is required to run YOLO. I'm gonna provide a link in the description that tells that shows you how to download and kind of make YOLO run on your computer for graphics enabled and without graphics as well. So let's start with the first step. Okay, so first step will be like kind of getting the data to feed into your model on which your model will train. So as I'm working on a dental cavity detection, we'll go search for some cavity images like intraoral images. So I'm just gonna search cavity, um, or I can just search for dental cavity dataset. So you can like find many websites. It doesn't matter where you get it from, and it doesn't matter if it's already annotated. I mean, if it's already annotated, then you can just download and kind of train your model from the get-go. But I've tried that, and even I'm a beginner, so I've tried downloading the images that were already annotated, but I was running in some problems, so I decided to like annotate it on my own. So the first thing you're gonna get is this Kaggle website, which is very popular. Like it has multiple data sets. So like this, you can see like I have here I have many cavity images. The one that I used was this one. So somebody, I think the one who posted this already annotated it, because you can see, as you can see here, there is also already a labels folder. So I tried training on this, but for some reason it didn't work for me. Like when I was trying to predict the images, it wasn't labeling the right thing. So after downloading this, what you'll get is these images over here, and I deleted that labels folder that was already present because those annotations I did not know how to work with those. So I'm going to annotate them myself. And what you do is just all of these images, you copy and paste them into a separate folder, like you keep them together. And now you will start annotating. So how do you annotate? So you can use different softwares for that. You can use CVAT, or you can use LabelIMG, which is very beginner friendly and very easy to set up and all. So I'm going to show you how to kind of use LabelIMG. So let's open our command prompt, and here let me just activate my env, activate TensorFlow. Then it'll take just a couple seconds, and you can just pip install label img with the I capital. So after you do this, it's gonna install for you, and since I've already installed it, I don't need to install it again. So after installing this, what you'll do is you'll just simply write label img, enter. So it'll take a couple seconds to open. So yeah, this is what you're gonna get. So to start annotating, you just click this and you go to wherever you downloaded your dataset. So this was mine and this was the image. You select folder and it'll open automatically, and you can use these buttons to like kind of go left and right. I don't know why it's already kind of annotated. Oh, because it's already showing these bound boxes because the save directory is here and I've already labeled these. So I'm going to show you again how to kind of make your own labels. So just go to wherever your dataset was and just create a new folder called labels. So since in this case labels is already there, I'm just gonna do tutorial underscore labels and enter and just select the folder. So then you can see all the labels have disappeared and you can annotate this on your own. So yeah, you're gonna annotate it like this, and you're just gonna write the class name. Let's suppose for me it was cavity, and it's just gonna add it over here and just save it. Since you've already selected this directory, it'll get saved in this, and you can just go next and you can annotate it again. And let's see, it starts here, and over here you can just put cavity, and over here as well you can just do it like this and cavity. So we'll just save it, and for the rest of the 252 images you can do it. And keep in mind, for need to keep some images that don't contain cavities so that the model recognizes that if uh, if a tooth does not contain cavity, what it looks like. Okay, so you'll notice that in these data sets they may have like some normal images just like this and some images without any cavities. So you're not gonna annotate them, you're just gonna skip them. So after you're done with annotating all your images, you can just go to your labels folder and open it, and you can see here that you'll get your annotation text file and your class files. Like if you have multiple classes, then there'll be like cavity, severe, moderate, low, just like that. You'll get a bunch of class names. And in this, if you can see here, is this is the class name, like the class ID. So if you for now we just have only one class, so that is cavity, so that's why it's just 0. Let's suppose you add more than one class, so it'll be like 1 to 0 based indexing you'll add. So and yeah, so this is the class ID, and these four numbers right here, these are, so this is the x coordinate, this is the y coordinate, this is the height of the bound box, and this is the width of the bound box. So these four numbers tell the model like where exactly the bound box is located in the image. So one thing I forgot to mention is your LabelIMG might crash when you're trying to annotate because it will show some kind of float or some integer error. I don't know. I fixed that and I uploaded those files that are causing that error, and I've uploaded on my GitHub. So I'll put the link in the description. You can just paste it wherever these files are. So for me, these files are, what you're going to do is you're going to edit the code in these in the canvas.py. Here you're going to edit the code, and the other place where you have to edit is, yeah, you're going to go to this folder, and you're going to download these two files and you can paste it, so it'll work fine. So basically without changing the code you can't zoom in, you can't edit, it'll crash otherwise. So you just download this and these two files and paste it wherever I showed you. And after that, so next step will be, like I mentioned, there are going to be images where cavities are not there, so you can't label anything. So for that, there won't be any text file for this particular image. There won't be any text files, but you need that text file in order to train your model. So what you're gonna do is, so you're gonna get that code from kind of, you can ask ChatGPT to make that code for you. Like you can just prompt it to write a Python code that can kind of generate empty text files. So it'll be quicker that way. So after you do that, what you can do is, yeah, so basically the hectic part is done already. So the next step will be to train the model. So what you're going to do is, now you're going to open your IDE. In this case, I'm going to use Jupyter Notebook, and you're going to go to wherever your folders were, and you're going to create a new Python file. Okay, then once you open this file, so what this code is, here I pasted some code. So what this code does is, as I said, there are going to be images where cavities are not there. So for those particular image files, there aren't gonna be any text files, annotation text files. But YOLO needs those empty annotation text files for training. So how do we create them? So this code. So what it does is, you have to kind of specify the path of wherever your images are, specify the folder where your labels are, and then it's just going to create a list of those images, and for each image it's going to check whether that file exists. So if not exists, os.path.exists, then it's going to create an empty file like this with open label path right, and it's going to pass. So it's just going to create an empty text file. So let's suppose in our case, we have this file and we have these annotations, right? So for now I only annotated two, and I'm going to show you how it's going to create the empty annotation text files. So let's suppose you have a bunch of text files, annotation text files with annotations like these, and you want to create uh, empty annotations for like these images which do not have any cavities in them. So what you're gonna do is, so let's see, over here we have this, right? So instead of this, what we're gonna do is we're gonna copy this and we're gonna keep it here, and our image, wherever our labels folder is, we're gonna just copy that. So if we run this, you'll see that empty annotations file is created for unannotated images. And if we check our labels files, see it has created every uh, for every, like, since we didn't annotate the rest of the images, it created empty annotation files for all the images except for the first two. So that's what you're gonna do. So the next step is, we're gonna create a train test val split for these files, for both the image files and the label files. And for that we need to go into our IDE, and we're gonna paste this code. You can get this from ChatGPT. You can tell it what you want, and it'll just give you this code. And here you just need to specify your image folder location and your label folder location. And then when you run this, you'll see here that this output comes, and if you check in your folder, you can see that the train test and val folders are created. And it's just that you can see here that 70% of your images are going for training, 20% is going for validation, and 10% is going for testing. So the next step is going to be model training. So to train a model, we can just go to the official website, the YOLO documentation website, and over here you can just click over here, and yeah, just scroll down and you'll find the code that is needed to train a YOLO model. So first we're going to need this, and let's run this. And so they have given 3 lines of code for training. You can use either one of these. So since we're just going to make a very basic YOLO model, we can use this line over here. And since we're using YOLO V8, so instead of 11n, we're just going to mention V8n. And this n over here, it is like YOLO V8 nano. So since our data set is very small and we need a very simple model, we can use YOLO V8n. So if we had larger data sets, then I think instead of n, m would be there, xl would be there, like that. So we can just run this, and you're gonna find that it downloads the pre-trained model. And if you see right over here in the files, this gets downloaded right here. And also one more thing is, they have given these other two lines of code are if you want to build a new model from a YML, if you want to like change the weights and how the model kind of works. So you can use either of these files. Since we're building a very basic model and we don't need to go into that, we'll just use this line. Okay, so the next is model training. So we'll just copy this. We don't need the results variable. We can just simply paste it over here. And this, instead of coco.yml, we're just going to mention data.yml. And what is this data.yml? So since we don't have this file, we're just going to create it. Over here, you're going to press new and new file and data.yml. So basically what you're going to specify in this file is kind of the paths of your train, test and validation folders of your dataset, along with the number of classes and the names of those classes. So I'm just gonna write them here. So here what you have to do is you have to kind of specify your train folder, your test folder and your validation folder. So here I'm gonna write train and let's say test and val. Okay, and you need to mention the number of classes you have, the number of classes you've annotated for. In my case, I've annotated for 3 classes, so I'm just going to write 3, and you're going to write the names of those classes. Here you have to keep in mind that the order in which you put the names, that should be the same order like where the ordering of your, here you have, okay, here you have to keep in mind that the order which you specify here, let's suppose I'm specifying low, medium and severe. So this order, like, so this will be your class 0, this will be your class 1, this will be your class 2. You have to keep in mind that whatever you have over here, the order which is in your, you can see where is the class, let me find the, see the classes. You can see this this thing right here, the order right here. You have to mention the same order in your YML folder. So what we can do is, what we'll do is we'll just put severe here because now class 0 will be severe, class class 2 is low and class 1 is low and class 2 is moderate. So over here we'll do low and over here we'll do moderate, and over here we're gonna just specify the location of our train folder and test folder and validation folder. So we're just gonna go here and in images where we're gonna copy this and we're gonna paste it here. Okay, and we're gonna do the same for test and val. So after doing that, what we need to do is, yeah, this is done. So now we can just train the model. Yeah, so now we can go ahead with the training. So now here you just specify the data.yml and the epochs here. So 100, I guess 100 will be too much. 50 is fine. So what does epochs mean? So epochs is the number of times the model iterates over the entire data set. So the number of times it goes over the entire data set. So since the number of epochs is 50, the model will go through the entire data set 50 times. And after each iteration, YOLO kind of automatically augments the data, like it performs horizontal, vertical flipping, rotations, grayscale, image resizing, all that stuff, so that it to prevent overfitting, basically. So that's what epochs is. So if you have a very small data set, you could even train it for 100. Since data set is very small, this will just take a couple of minutes to train, and once this is done, and image size is 640. This is the standard image size that is there, and you can reduce this if based on the specifications of your system. If your specifications are, if your system is not that great, you can just reduce this size, and if it's a GPU enabled system, it's going to train really fast, and and if your system doesn't have a GPU, it will train basically, it will train slower. So let's run this. Right here you can see the model has started its training, and it's gonna train for all the 100 epochs, and after each epoch it kind of evaluates itself, and it kind of stores the model after each epoch. It kind of saves the model after each epoch, and it saves the best evaluated model, that the model with the best performance. It saves it in a file called best.pt, and the last model that was trained is basically saved in the last.pt file. So let this complete, and I'm going to show you the output and how to predict. So right here you can see that the model has been trained and the model is saved over here. So if you go to this location, and you can see that there are two files, the best.pt and last.pt. Best.pt is just the model which kind of scored the highest, which has the highest performance, and last.pt is just the model that was saved for the last epoch. So in this case, it will be the 100th epoch that was saved here. Doesn't matter if it had a lower or higher performance. So the highest performance will be stored here, and we're going to use this model. So you're just going to copy this, the copy its path, and we have to define the model again, the model which is trained. So YOLO, and over here you just specify this, and you're going to run this. After that, to predict, you can just write results equal to model dot predict, and here you have to mention the source. The source can be either a folder which contains multiple images, or it can be a single image. So if it's a folder, you can just paste the folder path. So I'll just go here, go to my downloads, and over here you can see that I have this image right here, this folder right here with bunch of images. I'm just gonna copy as path, and over here I'm just gonna paste it, and the next argument is the confidence score, the minimum confidence score. So the standard one is 0.25. You can keep it to anything. You can even keep 0.50. So what confidence score is, like what this argument does is, it's only going to display those bound boxes which has a confidence score of 25% or more. So the next one is save. Yeah, save is equal to true, and yeah, we can just run this, and over here you can see that the results have been saved over here, and we'll just go there, and runs, detect, predict, and here you can see that the result of our trained model. So it's able to detect all these cavities, and let's see over here as well. So the class name along with the confidence score, right here another image, low, and yeah, so that's it. And for the UI, you can just make it on your own. It's not that difficult. And if you want me to show you the UI as well, I've used Streamlit for that. Then I'll show it to you in the next video.
And thank you for watching.